Today we are going to create a character controller and add some simple game mechanics in Unity using C#. The first thing we want to do is set up a new scene. When you first open Unity, it actually opens the Unity's sample scene, and I like to go ahead and save my own scene first so I know what my scene is called. It's really important when you are saving your scenes that you stay inside of the assets folder. Unity's projects is each project is actually a project folder, and all of the files for that project need to be in their corresponding folder. Anything that you are going to use in your scene and any scenes that you create need to be inside of the assets folder. Inside the assets folder in 2018 and later, there's already a scenes folder, so we can just go ahead and save our scene in the scenes folder. And now I can see in my project window down here at the bottom, inside of the scenes folder, I can see this is the scene that I just created. So the first thing I'm going to do is I'm going to create a little bit of stuff in the scene. I'm going to create a plane first under Game Object, 3D Object, and I'm going to create a plane. This is going to be the ground that my character is going to walk on. The controls in Unity, if you want to look around in your scene, if you hold Alt on a Windows keyboard and left mouse to rotate around, this is rotating around whatever is in focus. You can also right-click to rotate around wherever is your viewing camera that you're looking through. The scroll wheel zooms in and out, and clicking and holding the middle mouse button allows you to pan side to side. If you ever find yourself that you've moved far away from anything you put in the scene, you can also hit F with an item selected, and it will bring that item into focus. So I have a plane in my scene. Now I want to create a cube, which is going to be my character object. So that'll be under Game Object, 3D Object, Cube. And this is going to be the object that I'm going to move around with my controls. To make it easier to see this object on top of the plane, I'm going to add a couple of different colors that I can use. So in my assets folder down here in the bottom, if you right click, you can create a material. And a material is a way to apply a color or a texture to objects in your scene. So I'm going to name this blue because I'm going to make this material the color blue. Once you've created your new material, we have in the inspector over here on the right hand side, we have this color swatch, which you can click on to choose a new color. And these are just standard color controls to pick the color you want to use. Now you have a material with a color property, and you can apply that to anything in your scene by just clicking on this material and dragging it. And anything you hover over, you can preview what it will look like with that color. So I'm going to attach this to my character cube just so that I can see it from the background. And next, I want to go ahead and make the script that is going to control my character. Before I get too far, it is helpful to name your cube so you can find it more easily once you've added stuff to your scene. So I'm going to name this player. And again, in my assets folder, I'm going to right click and create. Now, this time I'm going to create a C# script. This is going to be the script that is attached to my player. So I'm going to name this player. It's really important that right when you create a C# script that you name it right away. If you create a C# script and you click off of it, it's actually created a class called new behavior, and renaming it will make it so that Unity can't connect this file to the class that was created. So you want to be careful not to click off of it before you name it. So now I have my player C# script, and I'm going to attach it to my cube. And the way we do that is you can take your C# script and drag it down to this section in the inspector where it says add component. You need to have the player cube selected when you do this. And if you drag it right below the add component, you'll get your icon will change to show that you're attaching this to that object. So now I've attached my player script to this cube. Now let's go ahead and open up this player script and edit it. If you double click on the script, it should open it in Visual Studio or MonoDevelop, depending on the version of Unity you're using. Mine's going to open up in MonoDevelop, but Visual Studio works just as well. So the first thing that I want to do in this script is I'm going to add some checks for input. And the way scripts work in Unity is we have a start function and an update function. The start function runs once right at the beginning, and the update function runs once on every frame. And if we're looking for input from the player, we want to check for that in the update function, because that's we want to check on every frame if there is user input. So in the update function, I'm going to check for input. We do this with an if statement, which is a conditional statement. So we can check if, the input function in Unity is called input with a capital I, dot, and then we're going to do get key, which is for getting keyboard input. And we can either do dot get key or dot get key down. The difference is dot get key is continuously checking that key, and dot get key down checks once on the frame when that happens. So we're going to start with dot get key down to see how that works. And then in parentheses for get key down, we need to specify which key we're looking for. So the way that we specify a specific key is with key code, dot, and then the name of the key on the keyboard. And for now, I'm going to be checking for the arrow keys. So I'm going to type right arrow. Keycode.right arrow, this is the right arrow key on the keyboard. So I'm going to close my parenthesis for get key down, and I'm also going to close my parenthesis for the if statement. And an if statement should have an open and close curly bracket. Now in this if statement, if the player is pressing the right arrow key, what I want to do is change the position of the cube based on what the user is pressing. So if they're pressing the right arrow key, I want to move the character to the right. And one easy way to do this is to do transform.translate with a capital T. And then in parentheses, we have a vector 3, which is the direction we want to translate. So I'm going to do vector 3 dot right. So this is going to move 1 unit to the right each time I press down on the right key. We end that line with a semicolon. And now we can save our script and test this out. So I'm going to do Control S to save. We've already given a name to our script when we created it, so Control S just saves it with the same name. And back in Unity, I can hit play. And if we hit the right arrow key on the keyboard, we can see that each time I press the key, it is moving 1 unit to the right. If you select your player object in the scene, you can even watch here the transform. You can see the position. Each time I hit the right arrow key, the X value is going up by 1. So rather than having it be updating the position once each time I press the arrow key, what I might want to do is actually have it continuously moving while I hold down the arrow key. So I'm going to remove this down. So I'm just doing get key. Get key will fire continuously as long as you are holding the key down. So let's save that and see how it works differently. And there it goes. So that was moving really fast. And one of the things that's important to note is that Unity does not run at a consistent frame rate. It runs at a higher frame rate depending on how good your computer is. So if you have a really fast, really powerful computer, you'll have a higher frame rate. The problem with this is that means that your character controller will move at different speeds depending on how good the computer is that the person is using. So if we want to make this frame rate independent, we have a handy way to do that, which is to multiply our direction by time dot delta time. This is the amount of time that has passed since the last frame, and it's a very small fraction. So if you imagine if you're running at 60 frames per second, this would be 1 over 60, 1/60th. So regardless of how good your frame rate is, this is probably a very small fraction. So generally when you do this, you also want to multiply by a larger number to get back to a pretty normal speed. So I'm going to multiply by 10. Now let's save this and test that out. Now it's moving at a continuous speed, and it will be the same speed no matter how good the computer is because it is frame rate independent. So the next thing we probably want to do is allow the player to move back to the left. So this is set up to move to the right, and if we want to move to the left, we can just copy this and paste it and change right arrow to left arrow and vector 3.right to vector 3.left. Now we can save that and hop back into Unity to test it out. It's a good idea to test pretty regularly when you're writing new code because this will allow you to catch any bugs you might have before you get too far. All right, so now my character is moving left and right. Next, we probably want to add the up and down arrow keys. And the first way I'm going to do this is I'm just going to copy these two, left and right, paste them down here, and now I'm going to do keycode dot up arrow is going to be vector 3.up. And keycode dot down arrow is going to be vector 3 dot down. Save that. So now my character can move up and down and left and right. This isn't a very natural way to control a character. For the most part, generally, you expect your character to sort of stay on the ground, and maybe the forward and the up and down arrow key is actually for forward and back. This is a pretty easy change for us to make. We can just change our vector 3. Instead of vector 3.up, we could use vector 3.forward, and instead of vector 3.down, we can use vector 3.back. So now my character can move side to side and forward and backward. It's probably helpful at this point to change our camera angle. This kind of character movement, we would generally expect our camera to be sort of above the character and looking down. So if you select your camera, up here at the top, we have these move, rotate, and scale options. So for the camera, I'm going to drag the green arrow, the up arrow, and you can see a preview down here of what that'll look like. So I'm going to raise my camera up and switch to rotate. And here we have, again, we have 3 axes, just like with move. The red one here is this circle here. The green one would be rotating around the y-axis, and then the blue one is this rotation here. So I'm going to grab the red circle, and it's really important if you just grab anywhere, you're going to get some wild rotations. But if you grab the red arrow, you can just angle it to point down and switch back to the move to bring it up above. Now I have sort of a better viewing angle of my character. Now you might notice that at this point the character is not really stuck to the ground. It's just floating wherever I've placed it above the ground. And if we want to actually have it so that the character lands on the ground, and this would also give us the ability to add jump to it, we can change how our character movement works to use physics. So with my character selected, I'm going to come down to the inspector and do add component, and I'm going to add a rigid body. In this add component menu, you have all of the things that you could possibly add to a game object, and there's a lot of different options here. Rather than going through and searching each one, the easiest thing to do is to type in the search bar. So I'm looking for a rigid body, so I start typing it, and here it is at the top. A rigid body allows us to use gravity on an object, so I'm going to leave this checked. This allows the object to be affected by gravity. And now in my script, instead of doing transform.translate, which just moves the object, what I can do is I can replace that with a velocity for the physics object. So instead of transform.translate, I'm just going to go to each of these and change this to get component. This allows us to get the rigid body, which we just added. So in corner brackets, that would be rigid body, close corner bracket, open and close parenthesis. And now I have access to the rigid body on that object, so I can apply velocity. So I'm going to do velocity equals, and this is my right arrow, so what I want to do is vector3 dot right, and I'm going to multiply this by 20. And now I'm going to copy this for each of the other three. So I'll paste this, and instead of vector3 dot right, this will be vector3 dot left. And then for my up arrow, we're going to do forward. And for my down arrow, we will do back. Control S to save and test that out again. And now I can see once I tap an arrow key, it moves continuously in that direction. And I can also see that it is sort of tumbling around. I also do see that I have gravity applied, so it can then fall out of the world. So a couple things we need to do here. First of all, if you don't want your cube to tumble around wildly, at the rigid body component in your inspector, when you have your player selected, the rigid body component has a section called constraints. And if we hit this triangle to toggle this open, we can freeze the rotation by checking X, Y, and Z. This will keep the cube from tumbling all over the place. Next, I want to make it so that when the user is not pressing one of the arrow keys, that the velocity goes back to 0. So I'm going to change the way this is set up. Rather than having each of these as separate if statements, I'm going to make these else if. So only the first one is a regular if. After that, each one is else if. Then I can have a final condition, which is just else. By doing it this way, we can make it so that if they're doing one of these conditions, we will use this velocity. And if none of these conditions are true, then it will use this, this final else statement. So what I'm going to do here is I'm going to do get component rigid body dot velocity equals vector3 dot 0. So this will make it so that the velocity of this object is 0 in every direction. Let's save that and test it out. So that's working to stop my character from moving when I release an arrow key, but you might notice that the gravity is now being applied very slowly. We can see it a little more if I raise the cube up a bit. So I'm not pressing any keys right now, and it is just very slowly lowering down to the plane. That's because on every frame, it's attempting to stop all velocity, including downward velocity. This will be particularly noticeable if we try to add a jump. So I'm going to add two things here at once. First of all, I am going to actually add a jump condition. So this will be a new if statement at the top. And for this one, we want to do if input dot get key down. And for a jump, generally you want it to happen just on a single press. You don't want it to continue flying upwards for as long as you hold down. And also generally we use keycode dot space for jumping. And to keep in continuation with the way we're handling the other input, I am going to change this next one to else if. So we have if the space bar is being pressed, and the way that we're going to handle this is we're actually, instead of setting the velocity, we're going to add upward force. This will allow gravity to take over afterwards and pull it back down. So we'll do get component Rigidbody dot add force, and for this we will use vector3 dot up. Now, like I said, the way that we're handling the final else statement, this is actually going to prevent us from ever seeing this happen. We won't actually get to see the spacebar adding any force because it's immediately going to reset the velocity to 0. So rather than having this just be an else statement, I'm going to change this to else if. And the condition I want to check here is to see if the y velocity is 0. If the y velocity is 0, that means that the character is neither jumping nor falling, and so we would want to reset the velocity to 0. Otherwise, it won't reset the velocity. This will allow the character to continue falling or jumping. So else if, and this condition is going to use get component Rigidbody dot velocity dot y. So this is checking the y value of the velocity. That's the up or down velocity. And I'm going to check if it equals 0. So we use two equal signs to compare two values. So I'm comparing this value, the y value of the velocity, to 0. And if they are the same, then I'm going to reset the total velocity. So just because the y velocity is 0 does not mean that my x and z values are 0. So this will reset all three values to 0. So let's save that and try it out. So now my movement is working correctly. And my spacebar is actually not working because I need to multiply by how much force I'm adding. So adding a single unit of force is actually not enough. So I'm going to multiply by 200 so that I can actually see that. Let's try again. And so now I have a jump. I might also want to turn down the velocity a little bit for the different directions. Let's try making each of these 10. And in addition to that, I'm going to make my plane a bit larger. Make sure you save your script each time you test. If you don't save the script, it's actually going to be running with whatever was the previous version of the script that you saved. All right, so that speed actually looks pretty good, and the jump looks pretty good. So one other option for how to do this, rather than specifying a specific velocity, the other option is to use force for every direction, just like we're doing for the space bar. So I'm going to show how to do that. If you wanted to use force, this will allow it to gradually pick up speed rather than immediately going full speed. So what I can do here is Rigidbody, get component Rigidbody dot add force, and then in parentheses I have the direction that I want to add, which I'll keep as the vector3.right times 10. And so then I just want to do this for each of the other directions as well. So I'm removing the equal sign and I'm removing the velocity, and I'm replacing it with add force with an open and close parenthesis. And I'm doing this for each direction. The only one that I'm not going to do this for is the very last one, which needs to still be velocity, because this is setting the absolute velocity. If we add force of 0, it actually won't change how fast it's going. So let's save that and test it out. And, oh, I think, so the only one that's working right now is the left, because that one's, I see. So I actually need to multiply by more than 10 to get it going at a decent speed. So here, let's try, since the left one was the only one that was showing up, and that one I accidentally set to 100. So let's try setting all of them to 100 and save it. For adding force, you'll probably want to test those values out based on the size of the objects you have in your scene. So it's a little bit too fast. Let's try 30. And save it again. Test one more time. That's looking a little bit better. So if you're using a 3D game, then all of this is pretty much exactly what you would need. If you want to do this same thing with a 2D game, it's a pretty similar setup. So what I'm going to do is I'm actually going to make a new scene. And this is going to be my 2D scene. So first I'm going to save changes to that scene that I was working in. And so I've made a new scene. Let's do the same thing we did before, where I'm going to save scene as, put it in my scenes folder, and I'm going to call this demo 2D. And so to do a 2D character, it's pretty similar except the way we set it up initially. So rather than creating our 3D objects, I'm going to create a 2D object, and what I'm going to create is a sprite. When you first create the sprite, it's invisible because it doesn't have a sprite image to use. So over here in the inspector, this is where you can see the sprite image that you're using. So I'm going to click on this little circle here next to sprite, and I can pick from some of the default sprites that I have here. Just for testing this out, I'm just going to use one of the built-in sprites, but if you want to bring in a specific image to use, you can do that now as well. So I'm going to pick one of these squares, and my sprite is very small right now. If you click on your game window, you can see there's the sprite in the center. It's very tiny. So you can scale it up in order to see it better. So if you hover over the X, Y, or Z values, you can actually click and drag to scale those. So I'm going to make this very wide and also kind of tall so that I can use this as my ground. And we would probably want to use a higher resolution image. You can see it's getting very pixelated. But this will work for setting up our initial scripting for this. So I'm also going to adjust the position. And once again, I can hover over the Y, and I can click and drag to lower that down till I get to a reasonable place for my horizon to be. And maybe I want to make it a little bit wider so it goes all the way across the screen. Now, by default, when we brought in the plane and the cube, they actually had colliders on them. But in 2D, you have to add the colliders yourself. So I'm going to do add component. And the component that I want to add is a box collider 2D. For 2D objects, we want to use 2D colliders, and we'll also end up using a 2D rigid body when we get to that step. So this is going to be my ground, and now I want to make a player object. So once again, I'm going to do game object, 2D object, sprite, and let's make that larger so we can see it. We also need to select our sprite image, just like we did before. When you first create it, it's going to be invisible. So let's click on this little circle. Pick a sprite to use. And for sprites, you can actually just specify the color right here. So if I also wanted this to be blue, just like my character, I could select that color there. And we can set our size. You can also switch your view to be 2D in the scene, which will allow you to more easily position things in the scene based on a 2D layout. To get the camera to also render in 2D, the way to do that is when you select the camera, if you go to the projection, perspective means it's a 3D projection. Orthographic flattens everything out, and you can see the difference when I do that. It immediately flattens the horizon of the skybox. So now I have my character object, and this is also going to need a box collider 2D. And I also am going to need a script. So just so I don't mess up my 3D player, I'm going to make a second script. This one is going to be called player 2D. I believe a script name cannot start with a number, so we can't do 2D player. It needs to be player 2D. Also, make sure you do not use any spaces. You can't use spaces in a script name. So player 2D, I'm now going to attach to this object, and I'm going to rename this object also as player. So just like we did before, I'm going to take this script and drag it down to the bottom where it says add component. Let's double click and open this script up. And I'm going to copy a little bit of the code because it's going to be pretty similar. So let's go ahead and take all this code first of all. Control C, and then take it over here into the update function, Control V. And the things that are going to be different, it's pretty minimal. The difference is everywhere we're searching for rigid body, we're going to search for rigid body 2D instead. We also want to take out the up and down arrow because we don't need to do forward and backward movement because this is a 2D character, so it wouldn't make sense to move forward and backward into the scene. We just have left and right on the screen. So let's take that out and continue on adding 2D. So everywhere we have rigid body, we're going to change that to rigid body 2D. Make sure you don't have any rigid bodies left in this script. The other thing that we need to change is the vector 3. We don't have the concept of a vector 3 when we're talking about 2D, so we would use vector 2 instead. So vector 2 just has two values, where vector 3 has x, y, and z. A vector 2 just has x and y. So save that, and back in Unity, the one other thing we need to do is, if you select your player, we need to add a rigid body 2D to this object. Now let's hit play and test. So now I have my left and right movement, and I have my jump. And you might want to mess around with the numbers a little bit. Since we did these based on a 3D space, we might want to reduce the amount of force that we're adding. So rather than 30, here we might want to use 10. And let's save that and see if that looks better. The other thing is you might notice that it's not sitting perfectly on top of the ground. And if we select the ground, we can see why. We can see that this 2D collider is actually going all the way around, and there's some space in between the edge. So we can adjust the size of that collider by dragging. I'm going to drag it down. I'm going to set it to 0.14 or 0.14. And so that lines up better with the edge. Same with this character. We can see the outline goes a little bit farther around. So I'm also going to change this to 0.14 as well. And I'm going to save my scene right now, and I'm also going to save my script. And now we're going to test that out one more time. So that's a little bit better for the movement, and it also is now sitting closer to the ground, which looks better. So now we have movement set up for a character controller, either in 2D or in 3D. The next thing I want to do is add a few different mechanics. And I'm going to do this first in the 3D scene, and then I'll redo it again in the 2D scene. So I'll go back to my original 3D scene that I was working in. And I can see I'm still previewing in 2D. So I'm going to go ahead and click this 2D again to get back into 3D. So what I want to do now is add some interactions for the player in the world. The interactions I'm going to add are to pick up collectibles, to step on damage traps and take damage, and to pick up a key to unlock a door. So first thing I'm going to do is in my script, I'm going back to the 3D script now. So we have these two built-in functions, the start function and the update function. What we're going to do now is we're going to create a new function of our own. This is another built-in function of Unity, but it doesn't come by default in the script. And this function is void on trigger enter. And that needs to be spelled exactly correctly with a capital O, a capital T, and a capital E. If there's any misspellings here, it actually won't work correctly. So this function takes a parameter, it takes a collider, and you can name it whatever you want. General convention is to use other for the name of that collider. And this is a function, so it needs an open and close curly bracket. If you're using in Visual Studio, it'll probably autofill this in for you, and it might even add private before the void. That doesn't really matter for what we're doing. So now we have this new function, and the way this function works is anytime something with a collider in Unity collides with something else that's marked as a trigger, it will fire this function. So we can use this to detect when two objects collide with each other. So what I'm going to do is detect when the player collides with different types of objects. And to detect different types of objects, the easiest thing to do is to use tags. So what I'm going to do is I'm going to check if this thing that we collided with, which we're calling other, that's the name of the collider we're using, and we're going to check if that tag, so that would be other.tag, and equals equals allows us to compare. And a tag is a string, so a string uses quotes, and in the quotes I'm going to put coin with a capital C. This is going to be the tag I use for the collectible objects. Then I'll do close parenthesis and open and close curly brackets. Let's save that for now. And so I need to actually add this object into the scene that I'm going to collide with, and I need to add a tag to tell what it's tagged as. So let's add a new game object. We'll do a 3D object. Let's make it a cylinder. So if we take the cylinder, we can make it kind of look like a coin. I'm going to use the scale, and I'm just going to scale it, squish it down on the Y value so that it's a flat coin-shaped object. And then I'm going to rotate it so it's standing up on its edge. and we'll lower that down so it's close to the ground. To make it look more like a coin, I'm also going to add a new material. So back in my assets folder, I'm going to right click, create material. Call this one yellow because this is going to be a yellow color because coins are yellow or gold. And now I'm going to drag that new color onto my coin. Now in order for the collision to be detected, I need a couple of conditions. So the first thing is that one of the two objects needs to be a rigid body. My player is already a rigid body, so that's all I need there. Both objects need a collider, and one of the objects needs to be marked as a trigger. It doesn't matter which object, but when something is marked as a trigger, it will be able to pass through other things, and I don't want my cube to pass through the ground. So I'm going to mark my coin as a trigger. That's this checkbox here in the capsule collider is trigger. So now this can be used for the onTriggerEnter function. The other thing I need to do is add a tag, and with my coin selected, I can add tag up here where it says tag. By default, it's untagged, and this is the list of all the tags that I have access to. I'm going to add a new tag now. Here's my list of tags, and I add one with this little plus button. And so first I'm going to add coin with a capital C, and I'm going to go ahead and add the other tags that I'm going to use because I know I'm going to need a few other ones. I'm going to also need a key. I'm going to collect a key later. And I need a door. And I'm capitalizing the first letter of each of these just for convention so that I can remember later and spell them correctly. And the last one is going to be damage. That'll be for the damage traps. All right, so now I'm going to select my coin again, and this time I'm actually going to apply the tag. Before I was just switching menus to add new tags. Now I need to actually apply that tag that I made. So now this cylinder is tagged as coin. And I'm going to go back to my C# script. So if I collide with the coin type object, now what do I want to do? The first thing I want to do is get rid of that coin. So I'm going to destroy other.gameObject. Destroy is a built-in function for Unity and C# that destroys an object, but it can destroy components off of an object rather than the whole object. So we want to make sure to destroy other.gameObject. So it's destroying the entire thing. Then it ends in a semicolon. And we can actually just go ahead and test that out first. So Control S to save. And just so I have a little bit more to test with, I'm going to, in my scene, I'm going to Control D or Command D on a Mac to duplicate and move these coins around. So I have a couple of different coins to collect. And so now when I collide with the coins, they disappear. Now we probably want a way to keep track of how many coins we've collected. So I'm going to add a variable. At the top of my script, this is going to go inside the class, but outside of all of the functions. So the class here has an open curly bracket, and the closed curly bracket for the class is way down here at the end. Inside of the class are all of the functions and all of the variables. So I'm going to create a new variable up here at the top. It's going to be a private variable. Variables in Unity and C# are either private or public. Public means that it can be accessed by other scripts, but this is going to be the only script that I have, so I'm going to make it private. Now I'm going to make this an int, which is a whole number, and I'm going to call it coin count, which is going to be the number of coins I've collected. And I'm going to default set this to 0. Then when I destroy the coin, I'm going to add 1 to the number of coins I've collected. So I'll do coin count equals coin count plus 1. And I want to be able to see how many coins I have. So I'm going to use a developer output debug line, and only I'll be able to see this. The player who's using it won't see this. Later on, we can add text to the screen to show the player this information. But for now, I'll do debug.log. And then in parentheses, the variable I want to log to see what it is currently. And I'm going to do coin count, close parenthesis, and semicolon. Save this, and we can test it out. If we click on the console, this is where it will print out those values when I collect the coins. So here I can see it printed out the line 1, which means I have 1 coin so far. Now I have 2, and now I have 3. So that's collecting objects. The next thing I want to do is check for something else. So I'm going to go ahead and add the ability to take damage. So here I'm going to add if other.tag equals damage. This is going to check to see if I'm colliding with something tagged as damage. And in order to keep track of how much health I have, I want to make another variable at the top. This is going to be another private int. I'm going to call it health, and I'm going to set it equal to 100 at the beginning. So I want to start with 100 health. Then in my if statement, if I collide with damage, then what I want to do is take my health minus health equals health minus 10. Each time I collide with damage, I'll take 10 damage. I also want to do debug.log again so I can keep track of that value. Now let's add our damage objects to our scene. Make sure you save your script. So I'm going to add a new game object. So it's going to be a cube again. Let's position it on the ground. And I'm going to add a new material. This is going to be a red material. Red for danger. And drag that material onto my damage trap. Just like we did for the coins, I want to check the box for is trigger, and I'm going to change the tag to damage. Now I'm going to Control D to duplicate a couple of these around the scene. Let's switch back to our console so we can see what we're doing. All right, so I collect a coin. It tells me I have 1 coin. Here, if I step on the damage trap, I can see each time I stepped on it, it went down by 10. Now you notice we're not destroying the damage trap. Generally, traps stay in the scene so they can continue to damage you each time you step on them. And I can pick up a coin and switch back to show me I have 2 coins. 20, 10, 0. Now I have 0 health, now I have negative health. Generally, what happens in a game when you hit 0 health is you die. And so let's make our player die. What we're going to do is we're going to restart the scene. To do that, we need to add something to the top of our script. This using section, this allows us to use some built-in options in Unity. And what I want to do is I want to have access to the scenes. So I'm going to add using Unity engine dot scene management. This will allow me to change scenes. I don't actually want to change scenes, I just want to reload the same scene. So down here where I have my health, I'm going to add an if statement to check if health is less than or equal to 0. And I want to check less than or equal to because depending on how I add and subtract health, if I have damage traps that do different amounts, or if I had maybe 2 damage traps that the player could step on at the same time, I want to make sure that I'm checking if the health is ever less than 0 as well, because it's possible the health will never be exactly equal to 0. So if the health is less than or equal to 0, I'm going to do scene manager dot load scene, and I want to load scene 0. Let's save that. And now I need to actually add this scene to my scene list, and that's under build settings. It's in file, build settings, and it has just the sample scene in here right now, which we're not using. So I'm going to delete that, and I'm going to hit this button, add open scenes. Here's the scene that I'm working in, coding demo. And this is the scene number. The scene number is 0, which is the one I'm trying to load. Let's go ahead and save that and test it out. So I'll just keep stepping on damage traps until it's 0 and it reloads. Now you might notice your lighting changes when that happens. The reason why that's happening is because Unity has some default light baking going on, and if that bothers you, you can turn that off under Window, Lighting, Settings, and uncheck this box Auto Generate, and then from the drop down choose Clear Baked Data. It doesn't show up in a build of the game, it's just in the preview mode. But if it bothers you, just turn it off in the light settings. So next, I want to add a key that I can pick up and a door that I can unlock. So all of this still happening in onTriggerEnter. I'm going to add a new if statement. If other.tag equals key. This is going to be where I pick up my key. And I'm going to make a new variable for this. So let's hop back up to the top. Make a new private. This is going to be a bool, which is a boolean or a true or false value. I'm going to name this hasKey. And I'm going to start it equal to false. So I have a boolean called hasKey, starts off equal to false. And I want to, when the player picks up the key, I'm going to change this value to true. I also want to actually destroy the key because I don't want the player to continuously pick up the same key. So just like we did with the coin, I'll do destroy other.gameObject. Save that, and now in my scene I'm going to create a new game object. Let's do a capsule for this one just so it looks a little different from our other objects. And I'm just going to reuse the yellow color. Scale it down a little bit. And I'm going to mark this as trigger, just like we've done with the others. And I'm giving it a tag of key. Now when I pick up the key, when I walk over the key, it should destroy the key. But I'm not actually doing anything to check if I have the key yet. So let's add a door. Let's first add a couple of walls to make our door actually seem useful. So we'll do GameObject, cube, and make it look like a wall. Just scale that up a bit. So I'm walling off this back side of the level so the player has something they can try to get to. Control D to duplicate. And now I'm going to make a new cube, which is going to actually be my door. And just to make this distinct, I'm going to make one more material called green. Drag that onto my door. And the way colliders work is the collider for this door, it'll stop my cube from walking through. And we can see that in action. If I were to set this as trigger, I'd actually be able to walk right through. In fact, I'll show that first actually. So let's set this to trigger. And now when I hit play, I can actually walk right through that door. But I can't walk through the walls. So I don't want to be able to walk through the door. So I'm going to leave this marked not as trigger. So now I cannot walk through the door, which is what I want. But I do want to detect when the player walks up to the door. So I'm going to add another box collider. We can have more than one collider on an object. So let's make this one, it's helpful to make this bigger than the door itself. That way we can detect when the player gets close to the door. And this one I'm going to mark as is trigger. So I have one box collider, the smaller one that is not a trigger, and then the larger one is a trigger. Now I'm also going to tag this as door and save my scene. And now back in my C# script, I'm going to add another if statement. If other.tag is door, and now if I collide with the door, what I want to do is check if I have the key. So if has key. If that is true, then I'm going to, just for the purposes of testing, I'm going to just go ahead and destroy the door. In a little bit, we will animate the door to look like it's opening. But for now, let's just destroy other dot game object. Save that and test it out. So now I have the key, and when I collide with the door, it disappears so I can walk through. And if we want to just compare, if I walk up to the door without the key, so I don't have the key, and I cannot walk through the door, if I walk over and pick up the key, now I can walk through the door. So that's the basic mechanics of having a damage trap, having collectible objects, and having a key that unlocks a door. In the next video, I'm going to show how to make these a little bit more engaging and interactive, add some animations, add an animation to the door opening, and add some sound effects and particle effects just to make it a little more exciting. The last thing I want to do before I go, though, is I want to replicate this in the 2D scene. So I'm going to go to my demo 2D scene, switch back into 2D mode, and the script for the 2D player character, this is going to be almost exactly the same. So I'm just going to take all of this and copy again, just like we did with the 3D one. So Control C, copy, and then paste this. I'll put it after the update function, but before the final closing curly bracket. So Control Z to paste. And I do need to add in my variables at the top as well. So let's come back over here, copy those, and paste those up at the top. And I also need my using scene manager up here, using Unity engine dot scene management. Now the only difference here, since this is a 2D object, instead of on trigger enter, we need to use on trigger enter 2D with a capital D. And instead of a collider, we want to use collider 2D. That's really all that's different. Everything else should be exactly the same. The only scripting things I changed was on trigger enter 2D and collider 2D. And save that. So now we just need to put our objects in the scene. So I'm going to do game object, 2D object, sprite, and I'll first make my coin. So let's use this circle object, make it a little bit bigger, and I'm going to make it yellow. And we can put a couple of these over here. Make sure you add a collider. For a circle object, we want to use a circle collider, and we want to mark this as is trigger. Then I'm going to duplicate, Control D, make a couple more of these. And oops, I forgot to mark them as coin. So you can select all three at once and choose the coin tag from the drop down. Let's test that out first before we get too far. So now I'm picking up the coins. We can also check in the console just to make sure I can see that it was updating that coin value, the coins count, each time I collect a coin. Now I'm also going to add a damage trap, game object, 2D object, sprite. Use a square for this one and make it red for danger. And I'm going to put this low enough that the player could actually jump over it if they time their jump just right. once again, adding a collider. This needs to be a box collider 2D. Mark it as trigger. And tag this as damage. Test that out one more time. Now I can see my health is going down each time. And if I time my jump just right, it's a little bit too tall. We either want to make our jump height higher or our damage trap a little bit lower. Probably what I want to do actually is make my jump a little bit higher. So I can do that in my script. Let's add 300 for our force. Now I can actually jump over that damage trap. And then the last thing is adding a key and a door. So let's create another 2D sprite. I'll use the knob again and make it yellow. And I'm going to make this one a little bit taller and skinnier so it's not confused with the coins. Put it over here on the other side of this damage trap. And again, you'd probably want to use an actual image for this. So right now I'm just trying to distinguish it from the coin so that so as not to confuse the two. Then I also want to have a collider on this. I'm just going to use a box collider 2D for this one and mark it as is trigger. Tag it as key. And then lastly, I'm going to make a door. So what I'm going to do is actually move these coins to this side of the screen. I'm going to put the door over here, blocking my way to the coins. So once again, game object 2D sprite. Select a square, and I'm going to make this one green, just like we did for the other door. And we want this to be tall enough that the player can't jump over it. And once again, adding a box collider 2D. Once again, we need to add a second collider that's going to be a little bit larger. So we can adjust the size of this and set the second one to is trigger. And tag this as a door. Now let's test that out. So if I walk up to the door, I can't walk through it, can't jump over it. If I walk over here, try to dodge that damage trap, pick up my key, and now I can walk through the door. So that's it for the mechanics for both 2D and 3D. Make sure you save your scene and your scripts when you're done. If you're working with multiple people, one useful thing to note here is the collab tool. So if you have multiple people on your team, collab allows you to share the work that you've done here today with the rest of your team. If you click on this drop down, you can hit start now, which will create the collab version of your project. And then you can add your teammates with their email address. The first time you create it, it's going to add all of your files. You see a little plus icon next to them. You can also see that in your project window. You can see the plus icons. And up here you can add a description to say what you changed. So I'll say created 2D and 3D scenes. Hitting publish now, this uploads all of your content. And then you can add your teammates to your project with this little icon here. This will take you to the browser page for your project where you can add people by email address. Once they download or once they accept your invitation, they can download the project. When they first launch Unity, it will show up in the Cloud tab. This will allow you to share your project with your teammates. Anytime you have changes from a teammate to download, you'll get an orange arrow. And when you have local changes that you want to share with your teammate, you'll get an up blue arrow. In the next video, I'm going to show how to liven up these mechanics a little bit by adding some art and some sound effects and some particles and some animations. So that's it for the mechanics.